Hey everyone, and welcome to another Risky Business product demo. My name's Patrick Gray. The idea behind these product demos is we get one of the sponsors into a video studio and we can walk through a product because, often it's better to see how a product's working instead of just talking about it. And today we're going to be taking a look at Panther, which is essentially, I don't know what you'd call it. We're going to get them to describe that, but it's like next generation SIEM or something like that. We're joined by three guests today. We've got Casey Hill, who works as a product manager at Panther. We've got Doug Miller, who is an engineer there, and we've got Ariel Ropek, who is a threat intel type of dude. And we're all going to sit down and try to work through a demo and an explanation of what Panther is. Starting with you, Casey. Why don't you, I guess, start off by describing what Panther actually is?
Absolutely. So, as you mentioned, it's a next generation, or we like to think of it as cloud native SIEM. So that means we focus on high scale production monitoring in terms of the primary use cases we see is really, really high ingestion volume and being able to leverage out of the box Python detection as code. So being able to actually run through detections in real time, meaning as they're actually streaming into the system. And then we're excited to talk to you today a bit about what we see in terms of the future of investigation within Panther specifically, and really where we see that going in terms of making things easier to search across kind of disparate data that's hidden within your data lake.
Now, as I mentioned, Doug Miller is also joining us. And Doug, you're here to intro the demo. So let us know what we're in for.
Yeah, so we've got a threat intel scenario, but we're showcasing Panther's search feature, which for a long time we had just SQL as the search interface in Panther. And Panther was really a detection first product, but we've been focusing on search more heavily. And what the big feature we're demoing is our new query language, PantherFlow, which is a pipeline-based query language. So I've been working on it for over a year, so I'm really excited to kind of talk about it, and Ariel's put together an awesome scenario.
All right, cool. So let's bring it up. Ariel, you're gonna show us everything that Doug's just described. Like, where to begin?
All right. Well, so this is our lovely docs page. We're going to be looking specifically at PantherFlow. I put together a scenario around an alert investigation that we'll walk through and kind of showcase some of the power and the usability of PantherFlow as a piped query language. Without further ado, I'll jump right in here. So I'd like to kind of take this as a interactive kind of walkthrough where we're going to play the role of an analyst who just received this security alert and kind of walk through the investigation steps that an analyst would take to see, what's going on here. Is this, a real compromise or a false positive? And if it is a real compromise, what exactly happened and what steps did the attacker take? This alert is for new API keys being created in CloudTrail. You can see a description of the alert here. User API keys being created in CloudTrail logs in AWS. We get a nice AI-generated alert summary here that says a AWS access key was created for a new user, and that could potentially be a backdoor account or an unauthorized privilege escalation. Now, as an analyst, I'm going to skip down to the raw log message that triggered this alert. And what I'm really going to dig into here is the user who performed this action, which in this case is me, Ariel. So we're going to take a look at this user, what they did around the time of this alert, and see, kind of broaden the context around what happened around the time of this alert and see what else might have occurred. So I will jump over to our search interface. And the first thing I'm going to do is actually grab the timestamp of this alert. So this was created a few days ago, and we'll pop over to our search interface. We'll switch to PantherFlow mode to use the new PantherFlow piped query language, and I'd like to search against my CloudTrail logs. there's a lot of really nice autocomplete features here, just like you would expect in an IDE that you were writing code in. So the first thing I'm going to do is add a where clause, and I'm going to look for logs around the same time of that alert. There's this really nice between operator, which can look for things between two ranges. So we're going to parse that timestamp that I grabbed earlier, just like that. And I'm going to look at the hour around that alert. So that'll be the beginning, and then we'll parse timestamp for the end. And again, we'll just search 1 hour around the time of that alert. And then the other thing I'm interested in is, filtering this down to the user in question. And so for this demo, I'm going to focus on this user identity ARN field, specifically this last part after the slash, which is either the username or the session name, depending on the log.
So yeah, what else did this user do at this time?
Exactly.
Makes sense. That is like, yes, the first thing you would want to do, which is, I guess, why it's the first thing you're doing.
Exactly. Yeah, the context is really important whenever you're investigating an alert like this. So I'm actually going to add a new field here, and I'm going to transform that ARN field because I'm not really interested in the full ARN. I'm just interested in that last username piece. So in order to do that, I'm going to use the extend operator, and I'm going to create a new field called p_actor, and I'm going to set that equal to, I'm going to split the user identity. So using the strings.split, grab that user identity .arn, and I'd like to split on \. Now, this is going to return an array. Split that string into parts and return an array with each part. So I really just want the last part. In order to do that, we're going to look at the last index, and we've got to calculate the length of that array. So can do that.
And this is interesting already because, I've known you as detection as code people, but now this is just SIEM analysis by code as well.
Yeah,
Everything
exactly.
by code. Everything by code.
Threat hunting as code. Yeah. Great. So now I have a new actor field. I'm going to add another where clause, and I'm going to say where the actor is equal to Ariel.roback. And then we'll just sort on the timestamp, and that should get us started to see what else this user was up to around that time. All right. So a few other things were happening around that time. Let me add a couple other columns here to see exactly what they were up to. I'll also add that new actor field that we created. So this gives us a better idea of what was happening around that same time. We can see the user being created. That's this access key event is what we got an alert for. So a user called Snidely Whiplash was created, and a new access key was created for them. What's really interesting though is that a access policy was applied to that user. And in this case, it looks like a full administrator access policy to AWS.
Yeah.
So as an analyst, now I'm thinking, okay, this could be some real privilege escalation. But it doesn't look like the Ariel ROPEC user did anything else around this time.
No, I mean, that's a very sparse set of logs there and a little bit alarming, right? So I'm guessing now you pivot off that and look at what Snidely Whiplash got up to, right?
Exactly. And so this is really easy to kind of modify our original query.
Yeah.
I'll convert this to a list or an array, add my new username, and go. All right. So quite a bit more.
Yeah. That's the, that's not great.
Yeah. Something else happened here, as we can see kind of the timeline where, the first user stopped and the new user started doing things. So we can see some additional stuff happening here. New access entries being created, new roles being created. I'm actually going to add another field for the event source. And we can see what AWS services they were interacting with. And I can see here that, we're starting to pivot into EKS, Amazon's Kubernetes environment.
Well, and you got EC2 there as well, and lots of IAM activity, and then a pivot into stuff that does stuff. That's there's something extremely not great happening here in these logs.
Yep. So yeah, I'm gonna look at some of these create events to see what else is happening here. New roles are being created, and then there's an access policy that's being associated as well. And this one is especially concerning because this is the EKS cluster admin policy. So whatever this user was doing, they've now pivoted, moved laterally into the EKS environment and escalated their privileges there as well. And from there, it also looks like they're assuming a new role. So they're creating that role, they're applying those admin privileges, and then they're assuming this role under a new session name. So at this point, now I'm wondering, okay, well, let's broaden our search outside of just CloudTrail. Let's go check out our Kubernetes logs and see what else might have happened there. So I'll start by adding this new session name to our list, and then I'm going to use a really handy PantherFlow operator called union. And this is going to allow me to union together multiple tables in the data lake and search across all of them at once. So we're going to add the EKS audit logs and then the EKS authenticator logs. Now, at this point, if you've ever used a SIEM or looked at a log, you probably know that each of these log types is going to have a slightly different schema. The fields are going to be slightly different. So what we need to do now is create sort of a data model to link them all together and make them searchable. So we're not gonna clone or duplicate any data, but we're going to map certain fields into a common set of fields. So I know that in the CloudTrail logs, the ARN is here. In the EKS and other logs, it's going to be in a different place. So I'm going to add a new field called AWS ARN. And I'm going to use this really cool coalesce function. And while I'm typing this out, maybe Doug can chime in and give us a little bit more technical details on what coalesce is doing.
Yeah, so coalesce is looking at each of those input parameters and picking the first one that's not empty or not null. So the outcome of this, it looks like, as Ariel's typing, he's going to search through each ARN, the location in each log, and then the outcome will be that whichever one has a valid value will be stored in that new field, the AWS ARN field.
So I know that for CloudTrail, it's here. For EKS Audit, it's going to be in this field, and in EKS Authenticator, it's going to be in this field. And I still want to do that same transformation here. So using that new field, I will just replace that there, and that will give me just that last part of the ARN for each of those. I also want to add the action as a common field. So we'll add a P action. We'll use that same coalesce function, and in CloudTrail, it's going to be the event name again, which we've already used. The EKS audit logs have a concept of verbs. So we want to look at the verb plus the resource. Resource.
I mean, I can't say I've ever seen a query builder that looks quite like this, right? Like, there's a lot going on here.
There is a lot going on. It's not as complex as it as it looks at first glance. There's only a handful of functions, which is an intentional design decision to make it, powerful but simple at the same time.
Well, yeah, and you can lay it all out, right? Like, that's the idea. Instead of just, I mean, in so many of these query builders, they're just like, they're sort of like database query builders, and they're just like this giant string of nonsense.
Yeah. Well, this is like one of the reasons why I wanted to build a pipeline query language, right? Because, I mean, this is a 7-line long query, and it's a lot of text, but each line is its own kind of atomic thing.
Right? I mean, that's what I'm getting at, right? Like, normally you see a query builder, and it's just this single line that, it's hard to read, whereas this, because you're breaking it up, and it's staggered, it just makes more sense,
And there's only, I mean, we have 7 lines, but there's only 1, 2, 3, 4 different kinds of commands going on, right?
Yeah. And one of the things I love about having it on separate lines is you can do a command / and comment any of them.
Yeah.
So as you're going, you can kind of save your work, change the query as you go.
Well, and I'm guessing what a lot of people will do, I'm guessing is there it is, save as, right? There's a save as button. So you're going to build up some of these things and you're not going to be rewriting them every time. It's just going to be like, you'll have your standard IR workflows for different types of events and just pull them out of a drop-down or whatever. And I'm guessing you ship them with some defaults, right?
Yeah, that's the plan. We don't have any today, but that definitely will. Yeah.
Well, and you got to see what your users contribute as well, right? I'm guessing they're going to come up with the best ideas. It's usually the way it works.
Yeah, we've got a great community of users who contribute both detections and searches.
All right, well, we've got our results here. So what's going on here?
Yeah, so now you can see the results of our coalesce functions. We've got our actor column here, where you can see that we're pulling that field from EKS Audit, EKS Authenticator, and CloudTrail. So we've got a common field for all of those log types. And then we've created this P action field, which is the action being taken by that user. So we still get that nice event name from CloudTrail, but we also get this, verb plus object for your EKS log. So you can see, creating access reviews, creating namespaces, and finally, creating new pods within the cluster. Drilling into this one.
Is this going to end with crypto mining? It feels like this is going to end with crypto mining.
We've done a crypto mining scenario in the past, and I didn't want to do the same thing again. So while you could very easily take this and go crypto mine with this pod, not this time.
Not today, Satan.
We can see that this is a privileged pod. So if you wanted to, you could take this pod, you could do anything you wanted with it, including crypto mining. So this is sort of, the end of the chain for this demo. We've got, we've got the full chain of events where, a new user was created with admin privileges in AWS. They pivoted into EKS and elevated their privileges there to become full cluster admin. And now they're creating a privileged pod. And at this point, as an analyst, I'm escalating this to my incident response team.
To go look at that pod and find out what's going on there.
Exactly. Yeah, we've got enough data here to really be sure that this is a security incident that's worth escalating.
Yeah. I mean, I guess for some people watching this who might not have a lot of SIEM experience, I guess they wouldn't realize the magic here, which is to be able to, on the fly, correlate events across different log types with different structures, right? I mean, I'm guessing that's the point of this demo, is to show that, well, you can pull in this CloudTrail data, look at this EKS data, you can, have an ephemeral field just for the purposes of running a few queries to try to stitch this together. And I mean, the reason that's important is because with a lot of SIEMs, traditionally, unless you've set it up to be able to do that ahead of time, it kind of is very, very difficult, right? Am I about right there?
Yeah, no, you're spot on. For me, at least, the ability to correlate across data types and understand the full context of what's going on in your environment is one of the main values of a SIEM.
Yeah. Now, you've just looked at all of, all of this is AWS stuff. at the moment. What else can you start correlating across in these types of queries? Because I'm guessing there's more.
Yeah, that's a great point. If I go back to the original alert, we have all these Panther fields. So anything that starts with P_any is going to be an indicator field that exists in any log type. So this is Panther identifying certain types of indicators and putting them in a common place. So you could very easily grab all of the IP addresses.
Yeah, sort of like how Maltego used to do with like pulling entities out of unstructured data, right? Like it goes, this is an IP address, and then bang, it's like auto tagged as an entity, and then you can pivot off that and do stuff. So I'm guessing you've got the IP of the original user doing this weird escalation and then onwards and upwards. You could then take that and throw in a query and just see where else it pops up.
Yeah, exactly. And we also have here, I actually have something prepared for this. If I start a new search here, I've run that alert through a little script that pulls out all of those indicator fields, and we can really easily run a search, not just across AWS, but across our whole environment, looking for those indicators in other places.
Yeah. Yeah, I mean, that was actually the magic trick from Maltego years ago, is that automatic entity. They called it entity detection, but it could be anything from a URL to an IP to an email address to a hash value to whatever. The trick was that it could look at a bunch of text and just say, well, I know what that is, so now I'm going to categorize that and store it as an IP address or as an email address or as a whatever. And then you can, search across it and see, well, which IP addresses appear next to, which email addresses. And, from there onwards, you went with your sort of, cool network graphs and whatever.
Yeah, exactly. We also have this signals table, which contains not only logs that have matched against any rule in the environment, but also that logs that have matched against a signal rule, where you're kind of looking for interesting, not necessarily alert-worthy logs, but interesting logs that become signals that become context around other alerts. So it's very easy to search through the context of your security data in this way, and then you can also very easily, using the union function, add additional log types like we did in the other demo.
Now, I mean, there is a fine line between what's a detection and what's a response, right? Because what you've shown us is an alert that led to a fairly automated, a fairly automatable bunch of queries that escalated that from being, oh, that's probably something worth looking into, to being something that you could sort of categorize as malicious or not. So are you going to, how much of this is going to be automated by your users? Like, are they still going to need to click the investigate button once they've built up their, little query blocks like this? Or, what's the workflow going to look like, I guess, is the question.
Yeah, that is a great question, and I think there's a lot of opportunity to automate a lot of these things. Our users are very savvy when it comes to automation, and especially like using some of the APIs that we offer to take an alert that's been shipped to an external destination and then call back using the APIs to investigate and get additional details.
Are people going to start scripting that, I guess, is my question, which is like, you get this type of alert, then run all of this query, prepare it, analyze it, and I'm guessing you could do some automated analysis on what's returned through these queries, right? And get an indication, get a risk score.
Yeah, absolutely. And even going back to what you were saying earlier, Patrick, as it related to what we're looking to kind of build out in terms of out-of-the-box functionality, when you think about integrating with a particular log source, and then how that relates to both the detection that you're running, but also the actual investigation that comes with it. That's how we're starting to think about things in terms of how could I bundle an actual PantherFlow search that's automatically either bundled with that to help me immediately have a jumping off point, or even go that next step further, like you're saying, where automatically go and get me additional contextual information and either attach that as part of the run book, but essentially contextualize that alert in a better way for me out of the box when the detection is actually fired.
Well, and once you've done this sort of investigation, like you could take an output like that, throw it in an LLM, which I'm guessing is on your roadmap, and then you can get actually an indication. Usually, an LLM is pretty good at saying this is worrying or it's not.
Exactly, and you're spot on there. In terms of just the approach generally, we like that we're basing this in something that you can then look under the hood and see transparently. Here's how I fetched and got this information. Here's what it looks like, and then you're feeding it into an LLM for kind of that last.
Well, yeah, and I see Ariel's actually doing that in the background while we're having this conversation, where he's hitting the summarize with AI button. Can we have a look at what that summary looks like?
Sure. Yeah. I had one ready. It'll take a second here to generate, but it looks through all the JSON log data and it puts together a nice summary. It just takes a minute here.
Yeah, that's fine. It's thinking according to that output. All right, so there's our AI summary, and I'm just going to read it here. A malicious actor has created a new IAM user with attempting to gain unauthorized access to an EKS cluster. Critical security risk, series of events indicating a potential compromise of an AWS environment. I mean, it's pretty plain language, right? Like if you were to drop this as an email to someone, I mean, eventually if you can automate it so that this is what falls out the other side, is an email written like this, that's the future is here, right?
Exactly. Yep. Yeah, this would be a great escalation note to send to the IR team to start their response. The last thing I wanted to showcase here is these summarize and visualize operators. So if I run this, I'm now just going to summarize all those events we were just looking at by the actor and the action and put those in a nice chart for us to look at.
And as this is pulling up, Patrick, you're spot on in terms of kind of where we're thinking and where our head's at. It is, how do you start to combine this information together to automate more and more of the workflows and leverage what Ariel's doing here so that you can start to make more kind of intuitive suggestions to the user.
I mean, that's going to come from the SOC, right? Like, because they're going to find themselves every time they get that particular type of alert, they're kicking off this thing. I mean, then you just automate that, right?
Exactly.
So it's clear that you'll be able to automate a lot. All right, so what do we got here, Ariel?
So this is sort of a visualization of the full attack chain. On the right, this is sort of the beginning of the chain where the Ariel ROPEC user is creating the access keys and attaching the admin policy. And then this kind of teal color is where Snidely Whiplash takes over, pivots into EKS. You can see them attaching that admin role for EKS. And then it pivots into the EKS session where we're creating pods and doing other nefarious things. So yeah, and again, like at Panther, we think of everything as code. So not just detections as code. Now we're doing search as code, dashboards as code. And going back to what you're saying about the SOC analyst powering the automation, you saw how quickly we arrived at this relatively complex threat hunting query. And that's something that, that's accessible to a SOC analyst who can build these queries and then save this as a piece of code to then hand off to the security engineering team to automate.
I guess the final thing before we wrap it up is, you have shown us AWS queries and whatever. Like, what other sort of data sources are you going to squeeze into this thing? Because I'm guessing there's going to be, I know you do application specific stuff, like from Monster Web Apps for some of your huge like Silicon Valley clients and whatever. And I'm guessing you could sort of cross correlate some of the AWS stuff with that, with that application specific stuff. You're going to bring in like EDR logs and, just the whole shebang, or is it more, source by source that you do these queries for?
Yeah, I mean, we support all of those log sources. We're seeing a lot of multi-cloud nowadays, so being able to correlate across your GCP and Azure with your AWS logs is becoming more and more important. We see a lot of like Okta and identity management logs as a very, very common log source.
So this process that you just showed us, where you're looking at a time window just around those AWS logs, you could bring in logs from Okta, from EDR, from whatever, right? Around that same time.
Exactly. Yep. And using this union operator, it's very easy to add additional GCP, audit logs, all sorts of things can be unioned here and searched across all at once.
Yeah, excellent. All right, well, we're going to wrap it up there. Ariel Ropek, Doug Miller, and Casey Hill, thanks a lot for joining me to walk me through Panther. I mean, it's it's very, very cool, very hip, very modern, and I really enjoyed that. Thanks a lot to all of you.
Thank you.
Thank you, Patrick.
Thanks, Patrick.